Welcome back to the channel. So in this video, we will see what is voltage follower with respect to the op-amp application. Okay. So we'll draw the 5-terminal op-amp. Input is to the non-inverting terminal, and from this we'll connect it to output without a feedback resistance. Okay. So what is the job of voltage follower is whatever the input you have given, the same type of voltage you should get at the output. Okay. So output follows input, right? So here, how we can write is from the virtual ground concept, node B is grounded. Hence, node A also we should treat as grounded. VA is equals to VB is equals to 0. This is the first concept. Then after that, node A is directly connected to output. So we can write VA is equals to V output. So I will call this as something like here VA is equals to VB, and this is equals to what? Input. Which VA equal to VB equal to V in we can write. We can use that virtual current concept for two reasons. One is for 0 and the other is for whatever the voltage. So equation number 1, equation number 2. So equate equation 1 to 2 because here we can consider VA as V output, VA as V input. So here from the equation 1 and 2, LHS are equal. So RHS are equal, and it is like this. So here V output by V in can be written as 1. What is V output by V in? This can be written as voltage gain. So voltage gain of voltage follower is always unity. What is the voltage gain? Our output expression is output is nothing but input. Output follows input, right? So and voltage gain is always unity. So this is the concept of voltage follower, right? So very simple one, right? So after this voltage follower, right? It is voltage follower is acting as what? It is acting as a buffer in case of digital electronics. In case of analog electronics or analog signals, it is a voltage follower, right? So you should know this buffer as well as voltage follower. You should know that as a inverting amplifier as well as NOT gate. Both are acting like same. In case of digital circuits, it is not, and in case of digital electronics, it is inverting amplifier. Sorry, it is not gate. In case of analog electronics, it is inverting amplifier, right? So we will see comparator. What is the meaning of comparator with respect to the op-amp? Basically, op-amp is having two inputs and one output. So what op-amp basically acts as a comparator. It is going to compare two inputs and it is going to give you the output where the input is high, right? It will compare two inputs, which is high, that output is going to come, right? With respect to a saturation voltage, we will tell in terms of plus sat and minus sat, right? So it is going to compare how many inputs, two inputs, and it is going to give you the output. This output is nothing but which is high here. Out of two inputs which is high, that is going to come and append here. So what is with respect to saturation level, plus Vsat and minus Vsat are the two output voltages we are going to get, right? So that how we will see is, first one is non-inverting comparator, right? So first one is non-inverting comparator. So how to draw this non-inverting comparator is, you can write this input. Non-inverting means we should connect it to plus and it is minus. So it is ground. I will consider this as V reference, that value is 0. It is plus V and it is minus V and it is output voltage, right? So now how to see this? It has to compare these two input voltage. Now first case, when V in is greater than V reference, means this V in value is higher compared to this. So out of this, it is higher means this is our output which is going to come. What is that? It is going to come plus. Means V output value is plus V saturation level. That is what the here plus V sat. Suppose if V in is less than V reference, what is the meaning is this is less compared to this, means which is high. This is high. High means negative is high. So what is you are going to get output as negative Vset. So it will compare to which one is higher, that is going to come here. That is a simple one. So to draw the output waveforms, input is like this. Output we are going to write in terms of plus Vsat minus Vsat, right? When V in is greater than V reference, what is the output you are going to get? you are going to get the output which is plus Vsat like this, right? When V in is less than V reference, that is this portion, at that time you are going to get a negative Vsat. Then continue, right? So it is negative Vsat, right? So this is how it is going to compare, which acts as a comparator. Op-amp acts as a comparator, in which case non-inverting comparator, right? So now we'll see what is going to be inverting comparator, right? So inverting comparator means this is minus and this is plus, right? And we will see what is going to happen with respect to this condition. When V in is greater than 1, greater than V reference. What is the V reference value? 0, right? Which is a non-inverting terminal in this case. So when V in is greater than V reference means negative is more. Negative is more means what is the output? Negative will get it, Vsat, minus Vsat. V in is less than V reference. V in is less compared to this, which is more. This is more, plus is more. So what is the output? Plus Vsat. So here, what is the type of output waveform you will get here now? You will get the output waveform which is opposite to the previous one. Means here you can just observe what is going to happen now, right? So this is, I call it as 0. When V in is greater than V reference, what is minus Vsat? So you will get minus Vsat here, right? Then when it is less than, you will get plus Vsat. So here it is like this, right? Opposite to non-inverting. So if it is positive, you will get negative, negative, positive you will get it, right? So that is what the thing is. Suppose if you are taking here non-zero reference. Now reference I have taken as 0. Assume that I will take a non-zero reference. So here it is 0. I will take B reference like this. B reference is here now. So at that time your waveform changes, right? So how? This portion I will write it as like this. Now V reference is this, right? So this portion is V in greater than V reference, right? So for this portion, what is the output you should get? Minus Vsat. So here for this portion I will get minus Vsat. So I will write here as 0, it is minus Vsat. Again now this portion, when it falls below this, it is V in from this portion to this portion. What it is? V in less than V reference. So for that portion from here to here, what you will get? You will get opposite, that is when it is less than you will get V plus. So here I will be having plus Vsat, right? Again here it is minus, again it is. So the difference between this and this is, it is with reference is 0, it is reference is not 0, it is some voltage, right? At that case, inverting comparator acts like this. Okay. Thank you. In this video, we have seen what is voltage follower, what is comparator. In that comparator, what is inverting comparator, what is non-inverting comparator. Whether it is inverting comparator or non-inverting comparator, basically it is going to compare the two inputs. If which input is higher, that output voltage will be coming as a result. Okay. Thank you. We'll see in the next video. If you have any doubts, you can put it in the comment section.